Hello students, this is me Ghulam Mustafa. Today we will discuss the topic Euler formula from the same chapter, planarity of the graph, and we will look its proof. What is Euler formula and what things shown by the Euler formula? Let's study. Euler formula is the basic computational tools for the planar graph. What is the statement? A statement of the Euler formula is that if a connected planar graph G has n vertices and E edges and R regions are faces, then it can be written as n minus E plus R is equal to 2. In other words, you can write it as n minus E plus F is equal to 2, where F is a faces or regions. So let's prove this statement or this expression. We prove by using induction. Step 1 or basis step that we use for the proof of induction. If E is equal to 0, it means that a graph having 0 edge, then G must have one vertex. Or in other result, if E is equal to 1, if a graph having one edge, it is not necessary, then number of vertices of G is either 1 or 2. Example of this one is, this is a loop. You can say this is a graph with 2 vertices. Step 2 or hypothesis. Suppose that result is also true for any connected graph with E minus 1 edge. Or step 3, now we add one new edge K to G from a connected graph, which is G plus K. There are following 3 possibilities. If we are adding other vertex, other edge K to the G, it will become G plus K. Then 3 possibilities occur over there. One is that K is loop, in which case a new region bounded by the loop is created, but the number of vertices remains unchanged. And second possibility is that K joins 2 distinct vertices of G, in which case the region of G is split into 2, so number of regions increased by 1. It means that when you are splitting 2 other vertices, distinct vertices in the graph, then there is other region created or increased by 1. Third possibility is that K is an incident with only one vertex of G, on which case another vertex must be added. In previous statement already we have discussed, if any plane connected graph with E edge is a form of G plus K. For some connected graph G with E minus 1 edge and a new edge K. Hence by mathematical induction, the formula is true for all planar graph. Graph on other surfaces. How looks a graph on other surfaces except xy plane? A graph is planar if it can be drawn on a plane or equivalently on a sphere. How about other surfaces? Just like is a donut, this is a donut and this is the graph on other surfaces, you can say as that. By using the property of the topology says that any reasonable surface, either it can be closed, bounded or orientable or continuously deformable to a sphere with a number of handles. It means that just like if you have a straight rope, you can make from that straight rope a square, a triangle and any type of the figure by deformation. So a sphere with handles, this is known as the handle of the sphere. So what is generalization of Euler's theorem? Euler's theorem was that n minus E plus F is equal to 2. So how we can write in the form of standard form or general form? If G is a connected graph of genus G, what is genus? We will discuss later. With n vertices and m edges, you can say is that this is the other surface that when you are adding G plus K when you obtained G plus K graph, and the face or the region which is made in the G plus K graph is compared to the G graph, then that surface or that face is known as the genus. Then it can be written as n minus m plus f is equal to 2 minus 2g. A graph is planar if g is equal to 0, otherwise graph is